In today's module, we're going to be looking at DNS security. But before we actually look at DNS security, let's kind of understand what is DNS actually. Okay, so we have a human here, and he has his computer here sitting in his house, okay, with his browser inside here. And what he does is he wants to go to www.google.com. So he types that in his browser here. Now the problem here is that while humans understand google.com, the browser doesn't work by these names. It works by IP addresses. So really what we want to do is convert www.google.com to the IP address, and then the browser can use the IP address to get to google.com. So the first thing it's actually going to do is it's going to check in its cache, right? So there's a local cache here, and it's going to check if actually there is google.com in the cache, and it finds that it isn't, right? So then what it does is going to go over to the ISP. So here's our ISP. And then in the ISP, there is a DNS server. And there's actually many DNS servers here, right? But this DNS server is basically a recursive resolver. Now, the recursive resolver is also going to check in its cache as well. And it doesn't find the IP address for google.com. So then what it's going to do is going to go enter a whole process here. And we're going to define that whole process over here. Okay, so the whole process here starts with the root name server. So you're going to go to the root name server, and it's basically going to say, okay, you want to go to google.com. So the first element is, I'm going to send you to the .com, the top level domain server. So it's going to give its IP address for the TLD, and then it's going to go over to the top level domain name server. And then it's going to say, okay, you want to go to google.com. So it's going to give the IP address of the authoritative name server of google.com. Okay, so it's going to go to the authoritative name server. And then it's going to return the IP address of google.com. And then the recursive resolver, the DNS server, is going to return the IP address of google.com. And then it's going to use the IP address to get to google.com. So essentially, if you look at it here, what DNS basically does, it takes the name, the domain of where we want to get to, and it converts it to the IP address, which is what the internet and browsers and everything works on, and it then goes and then allows you to connect to that domain. Now, let's say there is now another user. This is a different scenario here, right? So we have a different user here in the house as well. And inside there, in the browser, you also again type in www.google.com. Now, it will check its cache first of all, and it will say it isn't there. So then it will send the packet to the actual DNS recursive resolver, which is basically, it could be in your ISP. But it cached it this time. So it cached to Google, and then it comes back and gives the IP address, and then that user can go over to google.com. Now, when this user over here types in google.com again, it will look it up in its local cache, and then it will continue, and doesn't need to go to the recursive resolver. It doesn't need to go to the ISP. It just goes directly to Google. So you understand the powerful mechanism of caching here. And it's very important because when we look at it from a security lens, then basically the caching is going to be important. Now, so what can go wrong here, right? So now let's look at it. Now that we know what DNS is actually doing here for us, right? You can understand that there are certain attack vectors that can exist here that can actually inject some malicious domains here, right? So let's say this user wants to go to google.com, genuinely says, hey, I want to get to google.com. But we on the internet set up a malicious fake google.com server. So this is our fake Google server. So how would we get this user to go to the fake Google server? So one way we could do is we could hack this DNS server in here, and we can inject with a fake IP address so that when this user types in google.com and goes to the DNS server, we force an entry in there. We hack that DNS server to give it a fake IP address. So it will get the fake IP address from which will be provided by the DNS recursive resolver, be sent to the browser, and then the browser would go to the malicious website. This user here will be none the wiser. And what actually happens is, because we actually hacked this DNS server here, the same thing could happen to this user as well, because it's basically using that same DNS recursive resolver. So that's one way, and that is actually called, that kind of attack is called it's called DNS poisoning. And basically because we're poisoning that DNS server. And it's kind of like dangerous, because if you look at it, this user over here is going to continue using that fake server as long as the cache is still valid. It doesn't even need to leave and go to the DNS server. So even if the actual ISP kind of like found out that the DNS server had actually been hacked, and they actually kind of fixed it, right? The problem here is the users, both those users in their cache is still caching the dangerous, fake, malicious website server information. So that's one way, DNS poisoning, right? And the easiest way we can actually fix that is actually to secure it. And if we secure that DNS server, what we're doing is we're using something called DNS security. And we can do a whole separate video on that, but basically the whole concept is to secure the access of this DNS server here, so that it actually isn't hacked in the first place. You know, there's firewalls in place and all that kind of good stuff, right? So that's the first thing we can do. We can make that secure, and the ISP could take extra steps to securing the integrity of that DNS server. Another way we can do it is another attack vector that could happen is on this side of the actual DNS aspects of it, when it's actually going and it's actually finding that IP address. And what we could do somehow in this area is we could inject a fake authoritative name server, a fake IP address in that system there. And basically what would happen is the ISP would get information back from this fake authoritative name server. So we basically, broke into this kind of model, right? So, but it would be at the lower end, at the authoritative name server level, and we will trick that way of actually introducing that. And the way we could solve this problem is in actual fact something called DNSSEC. And it's important to understand that DNSSEC is different from DNS security, okay? They're providing security on two different areas of the puzzle here, right? Now, what DNS security does is every time we do this mechanism of going back and forth here, right, is we introduce an element of authentication, okay, auth-n. And basically what it's doing is authenticating the top level domain, is authenticating your authoritative name server. So there's some form of verification, some kind of checking, and that's done through certificates, Okay, and we add an extra layer so that someone can't just bring up a server without going through the proper process of actually adding the authentication, having that verified by the hierarchical structure that exists over here. Okay, and that's what DNSSEC is introducing. Okay, but in all here, really the main concepts that we're looking at here is DNS potentially is a way of kind of like, taking you to malicious domains, right? If the information isn't checked properly. Now, there is one other way we could actually, there is one other attack vector that we can look at here. And that is from, let's say we have a malicious user here. So remember here, on this side of the process, it was all about setting up a malicious website here. On this side is malicious actors. Okay, and what they could do is they could do an attack to that DNS recursive resolver. Okay, or they could do an attack on the root name server, on the top level domain servers, the authority name. So it can do an attack there. And in actual fact, you can actually also do an attack to the actual Google DNS infrastructure. And what its intent would be to bring down those DNS servers, because if technically there is no, let's say there is no, I'm going to erase it, if there is no DNS server here, if there is no name server, top level domain name server, authoritative name server here, right? The question becomes is how does this user get to the internet? So if you wanted to, in theory, bring down the internet, you basically bring down the DNS server. So a lot of times when hackers are looking to bring down a website, right, they don't necessarily go, technically, they may go to the website and try to attack it with a DDoS attack, a denial of service, a kind of like attack there. But they could also attack the actual DNS server that is actually resolving it to get the user's traffic to the website in the first place. So a lot of different areas, and basically a way you could protect a DDoS kind of like attack would be to use some kind of like a firewall or a solution that actually has DDoS capabilities. And that kind of like, to sum it up here, a lot of different attack vectors when it comes to DNS, but at the same time, a lot of good security solutions to help mitigate some of these risks that may be posed. And that concludes today's module. Thank you.